Please, thank you. I would have made him wait, but you're a much nicer guy than I am. Isaiah, you alive? Lucy, yep. Michaela, yes. Jasmine, yes. Michaela, yes. Rose, yes. Mason, yes. Evan. Andy, thank you. Anthony, yeah. Ben, no. Anthony Baez, no. Maya, Jaden. All right. 2, 4, 5, 6, 7, 8, 9, 10. All right. All right, ladies and gentlemen, we will be taking our quiz in just a couple of moments. But before we do our quiz, I wanted to review a little bit with you. A couple of important reminders on the board, ladies and gentlemen. Number one, your test is next week, Wednesday. Okay? So if you want to do a Unit 2 retake, you need to come in Monday or Tuesday and get it done. Okay? Monday or Tuesday and get it done. Also, ladies and gentlemen, the last day that I will accept any late or missing work, that includes retakes on Unit 3 test, is Thursday, the 16th of November. After that day, the only thing that will change your grade will be the final exam work. So, questions? All right, excellent, ladies and gentlemen. So, what I have for you today, ladies and gentlemen, is this. Name these compounds. You've got, since there are 6 of them, ladies and gentlemen, I will give you 6 minutes. Again, the one with a Roman numeral says that it has a Roman numeral underneath it, so please make sure you include that Roman numeral. If you can't, skip it and move on to the next ones, because that's what you will be doing on your quiz today. Bless you. You're welcome.
That's a big
Capital O, little o. Capital O, capital O. I think they're fairly clear, ladies and gentlemen.
you've got two different pieces of matter. Nitrogen, which there is more of in the air, but has a smaller mass. Oxygen, which there is less of in the air, but a larger mass. So because of that, how would their temperatures compare? Would they be the same? Would they be larger? Or would they be different? If they're different, tell me which one has a higher temperature. Then what about their heat? Would their heat be the same or would it be different? If it's the same, you don't have to do anything over here. If one is larger, you have to tell me which one is larger. And then their kinetic energy. Which one has more kinetic energy? If they're the same, you don't need to do anything here. If one has more kinetic energy than the other, then you put down which one is larger. Same with the velocity. These are all things that are related based on our definitions of heat and temperature. So I'm giving you two things that matter, like giving you that tabletop and that iron bar. Okay? They're in the same room right now. So what do we know about their temperature? Okay? What do we know then about their heat? What do we know then about their kinetic energy? What do we know then about their velocity? The particles in it. Okay? You can leave right there. I'm just going to I will get into it. Okay. But name it without the Roman numeral. And I'll show you how to do the Roman numeral. You know what I mean? So just name it without, so that all you have to do then is see how I added the Roman numeral. Okay? This is needed. Glasses in.
All right, ladies and gentlemen, so let's go through naming these real quick. The first compound, ladies and gentlemen, Na is sodium. PO3 is phosphate. PO4, since it is PO3, it has lost one oxygen, so it becomes phosphite. Questions? Okay, so we changed the AT ending to an IT ending because we have lost one oxygen. So it ends up being sodium phosphite. Questions? All right, for this next one, CO is cobalt. Cl is chlorine, which becomes chloride in the compound. This is a binary ionic compound. So now we need to go through and we need to find the charge. To do that, ladies and gentlemen, I need to know two things. I need to know the number of the atoms in the compound, and I need to know the charge of each. Now, the problem is I don't know what the charge of the metal is. I do know what the charge of chlorine is. Chlorine is a -1. There is one of them in this compound. So that means the total charge by all the negative part of this compound is a -1. That means that the positive part of this compound has to be a +1. Has to, because the total charge on a compound is always 0. We don't know what the charge is, but I do know how many cobalts there are. There is one of them. So what number times 1 gives me a +1? That is the number 1. That is how we find the charge. Now, again, on your test, if you can't do this, don't let what you can do stop you from doing the other 18 or 19 problems that you can do. So at least put down the name. If nothing else, take a guess at the charge and move on. Okay? Questions? Si is silicon. Silicon is a nonmetal. That means this is a covalent compound, ladies and gentlemen. This means we are in our naming system that we talked about yesterday. So silicon. 2 of them, we put di in front. 3 nitrogens, trinitride. So the name for this compound is disilicon trinitride. Questions? Key is you have to recognize that it is a covalent compound. So you just don't name it silicon nitride. We need the prefixes in there. We never start a name with mono, but if mono is in the second part of your compound, we would put it there. There is always going to be a prefix in every covalent binary compound. So if there's none in the first, there will always be one in the second. Okay? So this one we know is a ternary compound, which means it needs to be ionic. So zinc, SiO3 is not on the back of your sheet. SiO4 is. SiO3 has lost 1 oxygen compared to the SiO4. So instead of silicate, this is silicite, I-T-E-N-D. Questions? Okay, again, a binary compound. So you've got to ask yourself, is this ionic or is this covalent? Because it begins with silver, a metal, it is ionic. So therefore, we are going to name this with our ionic system. Silver iodide. No prefixes because of the fact that it is a, ionic compound. Questions? All right, our last one, ladies and gentlemen. Right away, I could tell this one is covalent. Besides the fact that it begins with a non-metal, what else tells us that this is covalent? Joshua. But that could still be ionic. Jaden? It's not reduced. If it is 2 elements and it is not reduced, it has to be covalent. We would reduce it if it were ionic. So again, we're in our system with prefixes. 2 nitrogens, dinitrogen. Again, we do not change the ending of the first nonmetal. We just write it, dinitrogen. 4 means tetra. And then oxygen means oxide. Any questions on any of these, ladies and gentlemen? Okay. So then I would simply ask you to do these, ladies and gentlemen. Write formulas for these 6 names. Again, 6 minutes on the clock, ladies and gentlemen. Then we will go over them with you. If there's one you can't do, skip it and do one you can. Because again, on the quiz today, do the ones you can do. Get the points you can.
Today, while we're taking the quiz today, you can just send back from the other day. The notes that you've been missing, there is a new resource in Google Classroom. It's a video link to the lessons. Okay. Okay. Just so you know. Thank you.
It's usually on the test, not the quiz. And the changes that undergoes. Chemistry is the science of the study of matter, its structure, properties, composition, and the changes that undergoes. Has you been taking the quiz? Did you get close to it? See, what I need is like a bunch of Lonitas. So whenever I walk into the bathroom, everyone will walk out and they can
All right, ladies and gentlemen. Now you are welcome to do this how you please. If I were looking at a bunch of names like this, ladies and gentlemen, the first thing that I would do is I would look and I would find the ones that I believe involve polyatomics. So I am looking for anything that ends in an ITE or an ATE. So this compound right here, I know is going to have a polyatomic, the ITE ending. This compound right here, I know is going to have a polyatomic. Okay? Then I would also look and I would say, all right, which ones of these look like they are going to be binary covalent? Prefix here, I'm thinking binary covalent. Prefix here, binary covalent. So that I remember that that's a naming system where I have to use the prefixes, okay? Or where we use the prefixes and I don't need to reduce those, okay? That means, ladies and gentlemen, that these two others that are remaining, I'm going to look on the back of my periodic table and see if oxide is on there. Now, I do know that oxide is not on the back of my periodic table. Now, the reason I'm checking that is because there are a few polyatomics that end in IDE. Since oxide is not on the back of my periodic table, that means that these here, ladies and gentlemen, this one here at least, is going to be a binary covalent or a binary ionic compound. Sorry. Binary ionic. Okay? That means I'm going to have to do my charges and things. Gallium selenide, nothing on the back of my periodic table looks like selenide, so this must be a binary ionic as well. Okay, so for polyatomics and for ionics, I am going to have to work with those charges. So iron, Fe plus 3. Chlorite, ClO. Now, chlorite is one less than chlorate. Chlorate is ClO3. So this is going to be ClO2 and it's a -1. So therefore, ladies and gentlemen, I'm going to write my compound now by doing the charges like I need to, which means this is going to be Fe, parenthesis, ClO2, parentheses, 3 outside. Questions? Okay, binary covalent means that I'm just going to write down the symbol, phosphorus, P. Nothing in front of it means there's only one. Sulfide comes from sulfur. Mono means one. There is your entire formula, ladies and gentlemen. PS. Binary ionic. I'm going to write down magnesium. It is a +2. I'm going to write down oxygen for oxide. It is a -2. I will do the crisscross method, which means Mg2O2. However, these twos can be reduced. Final compound, MgO. Questions? Nickel 2 silicate means that it's a polyatomic. Nickel has a +2 charge. Why? Because of the Roman numeral here. Silicate, I go on to the back of my periodic table. I'm sorry, this is silicate. My bad. Silicate on my periodic table is SiO4. So silicate is going to be SiO3. Silicate has a charge of -4. That means I'm going to crisscross and do Ni4, SiO3 in parentheses 2. However, this also can be reduced by 2. which becomes Ni2SiO3. Since I am no longer putting a number down by the SiO3, it is not in parentheses. Because I am reducing this 2 and 2 down to a 1, I take away the parentheses. Questions? Trisulfur hexachloride, that is a binary covalent. Sulfur is S. Tri means there are 3 of them. Chloride is Cl. Hexa means 6. Boom, I am done. Gallium selenide. Gallium is a metal. Selenide is a nonmetal. That's a binary ionic. Gallium is Ga on the periodic table, ladies and gentlemen, and it is a +3 charge. Selenide, I need to find it on the periodic table. It is number 34, selenium. So that is Se, and Se is a -2 charge. So therefore, my compound is going to be Ga2, Se3. Questions? All right, get everything off your desk except your periodic tables, ladies and gentlemen. You may find this helpful on your quiz today. You may not. You could use it if you want. You don't have to if you don't want to. So again, now I realize there are 2 different things, ladies and gentlemen. One, as a Roman numeral, would be I. As a prefix would be mono. Okay? This is obviously for our covalent naming system. This is obviously if you need to tell the charge of a metal. So 2 is Roman numeral II. The prefix is di. 3 is III, prefix tri. 4, IV, prefix tetra. 5V, penta. 6, VI, hexa. 7, VII, tepta. 8, VIII, octa. I don't think I give you anything with a charge of 8. Okay? But I put the Roman numeral up there just in case. Same thing. I don't think I give you anything with a charge of +9 or +10, but I just put the Roman numerals up here because I was on a roll, ladies and gentlemen. Questions? Okay, Dante, you need to slide your desk over a little bit, create a little bit of space there. Okay, split the difference. Okay, all right, ladies and gentlemen. If you have questions during the quiz, please feel free to come up and let me know. I will give you a half an hour to complete the quiz. Should be more than enough time for you, ladies and gentlemen. Please make sure you put your name on it. We don't do a lot of things where you're turning them in, so occasionally people forget to put their names on it. It isn't so bad if only one person in the class does that, but when multiple do that, that creates a problem for me. If you feel that you need scratch paper, there is some up in front. Now, I did, when you get the quiz, you will see this big table at the start. Please let me explain what I expect for you to do with that, okay, before you start going crazy on it.
Is there any chairs?
Excuse me?
With your table, is there any chairs?
Well, do you think we need them on this?
Maybe if we're gonna have a
Well, I don't think we're having a Thanksgiving feast,
Okay.
okay? By then you'll be somebody else's problem because this trimester will be over.
And you second trimester.
So on the quiz, ladies and gentlemen, I gave you a workspace there. You do not need to use that. If you need to, you can. Down in the bottom, that is where you will write the formula for those 4 compounds. That workspace is there just in case you need it for doing the crisscross method, figuring out a chart, something like that. I just put it there. Nothing needs to be in there, but if you're going to put something in there, I am not grading that box. I am grading the one underneath that says formula. So please make sure your answer goes in that box underneath that says formula. Then there are 2 questions at the bottom, 3 and 4, that you need to answer. Again, they don't need to be a complete sentence, but they need to be a complete answer. On the back side, ladies and gentlemen, there are 2 that require a Roman numeral, and 1 I actually did for you. So this quiz is only worth 19 points, and there's an example of a formula there for you since I've left the answer in the quiz for you. Okay? So you only need to do the 7 of those 8 in question 5 and 6 because 1 is actually done for you. I think you might get that one right. Okay? And then there are 2 questions down at the bottom. All right? Go to work, ladies and gentlemen. If you have questions, raise your hand. If you cannot find an element or you need help with spelling, call me over. Please remember, minor spelling errors I will accept. If you write gallium with 1 L instead of 2, I will accept that. If your spelling error was you put ITE instead of IDE, no, I'm not going to accept that. Go to work, ladies and gentlemen. Okay, so acids, ladies and gentlemen, what are they? They're a compound that increases the hydronium ion, H3O plus ion, when dissolved in water. Okay? Now, what is the formula for water? H2O. So what we're talking about is a compound that will add another hydrogen to water. Okay? And since water is what we call a polar molecule, it will attract this hydrogen ion and it will make itself H3O plus. Okay? So the only way you can increase the hydronium ion concentration of water is acids have to have hydrogen in them. Okay? So acids have hydrogen and it is acting like a metal. In other words, it will be where in your compound? At the beginning. So Acids are easy to recognize. They begin with the element hydrogen. Now, there are a few minor organic acids that will not begin with the element hydrogen. We will not worry about those. Okay? All right, we will not worry about those. So hydrogen begins the formula, ladies and gentlemen. And the hydrogen is attached to either a nonmetal ion or a polyatomic ion. So the hydrogen is acting like a metal. What is the charge of hydrogen if it's acting like a metal? +1. So its charge is going to be a +1. Okay? Now, we're going to treat it like any other compound when writing the formula. So in other words, we're going to have to go back and do the crisscross method for acids. But now here's the good news. You will never have to reduce an acid's formula. Why? What's the charge on the acid? I'm sorry, let me rephrase that. What's the charge on hydrogen? 1. So when you crisscross them, you're going to be putting a 1 by either the nonmetal that it's with or the polyatomic ion. So you will never see an acid with the polyatomic in parentheses because the only thing you're ever going to put by the polyatomic would be a 1 anyway. Now you may see by the hydrogen in an acid a 2, a 3, a 4, depending on what it's with. But you will never see anything with the nonmetal or with the polyatomic. But one of the things that you have to do is to indicate that it is dissolved in water, because that's the only way you can increase the hydronium ion concentration, is after an acid, we put AQ in parentheses down next to the subscript or next to the final part of your compound. So that is another way of recognizing an acid right away because it will say AQ. Now, when we get into our next unit, next 2 units, other things can be aqueous. They can be dissolved in water. But all acids have to be dissolved in water. So, for example, HClAQ, beginning with hydrogen, AQ at the end, it's an acid. There are 2 kinds of acids, binary and ternary. Binary means just that, only 2 elements. Ternary means 3 or more. Okay? So to be binary, you're involving a nonmetal. To be ternary, you're involving a polyatomic. Questions? Okay. So, looking at that first compound, is that an acid, an ionic, or a covalent compound based on what we've told you so far? What? Acid. That is an acid. Begins with H, ends with AQ. That is an acid. Okay? That is an acid. NAS. That is covalent. Why, Morgan? Starts with the nonmetal. The next one, Mg3S2.
Acid.
No. It does have aqueous after it, but what doesn't it begin with? Doesn't begin with hydrogen. So what is this? That is ionic because it is beginning with a metal. Okay? HClAQ. Acid. H3PO4AQ. Acid. Si6. Covalent. Why? Nonmetal beginning the compound. PBH4 aqueous. Again, acid. I'm sorry. I updated it on your slides. Sorry. It's obviously not on yours. But acid, ionic, or covalent? That is ionic. Why? Lead is a metal. HBr.
Nope, not acid.
Not acid.
Oh,
Covalent. Covalent. Okay? Actually, it would still be ionic. Sorry. My bad. Hydrogen at the beginning would still be acting like a metal, but it's not an acid if it's not aqueous. Okay? I won't do this to you on a test. Okay? H2O, liquid. Hopefully. Hopefully what? Hopefully ionic? Actually, it's covalent. Now, here's the thing, ladies and gentlemen. Okay? There are exceptions to all rules in chemistry. No exception to that rule. Okay? Water is a covalent compound. Some would say it acts ionic at times. Okay, so be it. Here's the honest to goodness truth. No compound is ever truly ionic or truly covalent. Most compounds, even if they are covalent, they have a little ionic tendencies, and ionic have a little covalent tendencies. Okay? Again, if there is a metal at the beginning, it has to be ionic. If there is a non-metal at the beginning, it has to be covalent. Hydrogen can fool you. Hydrogen can act like a metal, it can act like a non-metal. Okay? It can act like a metal, it can act like a non-metal. The reason we're saying this is covalent is because hydrogen is actually sharing electrons with oxygen. And electrons are sharing, or the oxygen are sharing electrons with hydrogen. HNO3 aqueous is an acid. How about CH4?
Covalent.
Covalent, definitely covalent. How about HC2H3O2 aqueous?
Acid.
That is an acid. That is an acid. All right. HCl, binary or ternary? Why? Two capital letters. H2SO4,
Ternary.
ternary. HClO3.
Ternary.
By the way, these are all already what? Just so we're clear.
Acids.
These are all already acids. The question is, are they binary or ternary? H3N, binary. H3PO4,
Ternary.
ternary. H2S,
Binary.
binary. By the way, you can put B, you can put T. I know there's a lot of typing there. Or you could put one down and you could copy and paste it into the others. HC2H3O2, ternary. H2CrO4, ternary. HI, I, binary. HC2O4, ternary. H4C, binary. HBr, binary. Now again, what I want you to notice, okay? We don't put anything by the acetate. We don't put anything by the CrO4. We don't put anything by the I. We don't put anything by the C2O4. Why? The charge on hydrogen is always a +1. So all we would be doing is putting a +1 by it. But because C2O4 has a -2 charge, we need to put 2 by the hydrogen. Because iodine has a -1 charge, a 1 goes by the hydrogen. Because CrO4 is a -2 charge, a 2 goes by the hydrogen. So we are still doing the crisscross method, ladies and gentlemen. It's just the only thing that you will ever put a number by will be the hydrogen in these compounds. Questions? Good place to stop for today, ladies and gentlemen. On Monday, we will start naming them binary and ternary. Tuesday, we will review. Wednesday, we will take our test.
Before your anxiety gets you. Mr. Murphy,
Yes.
are we going to have acid test?
Are we going to have what?
Acid test?
Yes, definitely.
Why did I think the quiz was going to be 60 points?
Definitely.
Because that's a test that's going to be 60 points.
The test is going to have 60 compounds that you will either name or write the formula for.
Okay.
And then another 10 points of other things.